Hello, and thank you for listening in today to this presentation on the low temperature thermochronology of the Pine Creek Orogen and Arnhem Province in Northern Australia, and their links to the Central Australian Alice Springs orogeny. Firstly, I would just like to thank the MinEx CRC and its sponsors who have supported this work. The Alice Springs orogeny is an intercontinental orogeny with deformation and metamorphism focused in the Amartis Basin and Arunta region of Central Australia due to the presence of favourably oriented local structures and localised crustal weaknesses. North-south oriented compression between about 450 to 300 MA caused major thrusting and shortening in Central Australia, driven by changing stresses at the plate margins. Paleozoic sediments deposited coeval with the orogenic event are common across much of Central Australia and suggest a pattern of widespread denudation linked to regional uplift at this time. To investigate the impact of this event further from the locus of deformation, we have investigated the low temperature thermochronology of two northern terrains using apatite fission track and apatite helium methods. The first study area I'm going to talk about is the Pine Creek orogen. This is the Paleoproterozoic terrain which experienced regional metamorphism at around 1865 to 1850 MA, followed by subsequent post-orogenic granite emplacement within the Central and Nimbua domains. The Pine Creek orogen is also overlain by several Paleoproterozoic to Cenozoic basin systems. However, potassium-argon ages of around 1750 MA preserved in the region suggests that there have been no major thermal events following this initial phase of metamorphism. In this study, we sampled from the Cullen supersweet granite around the Pine Creek shear zone in the central domain and analysed these apatite samples for fission track and apatite uranium-helium thermochronology, as well as apatite geochemistry. The resulting low-temperature thermal models have been calculated using a combination of apatite fission track and, where available, apatite helium data. Additionally, we have used detailed single-grain geochemistry constraints on annealing kinetics, referred to as the RMRO parameter, which incorporates data from both laser ablation and electron microprobe analysis. These thermal history models predict a complex evolution within the Pine Creek orogen, comprising of two major thermal events. The first of these events is a cooling phase between 400 and 300 MA. This cooling is coeval with uplift in Central Australia during the Alice Springs orogeny, and is interpreted as driven by uplift and denudation in the Pine Creek orogen during this orogenic phase. While the Pine Creek orogen is about 600 km north of the locus of deformation in the Alice Springs orogeny, it is actually much closer to the northern plate margin of the North Australian craton, where stress may have originated before propagating to the continental interior. While deformation in the Pine Creek orogen is notably less than observed in the Amartis and Arunta regions, this cooling event does suggest that compression during the Alice Springs orogeny did have an appreciable effect on the shallow crust away from the Central Australian region, most commonly associated with this event. Following Alice Springs related cooling, the Pine Creek orogeny basement was exhumed to the surface as evidenced by the presence of a regional unconformity, before experiencing a secondary reheating event in the Jurassic to Cretaceous. This later reheating event is temporally consistent with deposition in the Money Shell Basin, north of the Pine Creek orogen. Sediments of the Money Shell Basin are preserved as remnant outliers within the Pine Creek orogen today, providing evidence the basin once extended on shore. The onset of reheating in the region and deposition of the basal unit of the Money Shell Basin, the Plover Formation, correspond well with mantle downwelling as predicted by global models and induced subsidence in the Pine Creek orogen, as shown in the figure on the left. We suggest that reheating in the Pine Creek orogen was caused by burial and thermal insulation by Money Shell Basin sediments above the Pine Creek basement during a period of marine transgression. This marine transgression was potentially facilitated by mantle-induced subsidence in the region, which provided accommodation space for deposition of sediments during this time. We will now move on to the second study region of this presentation, the Arnhem Province. Much like the Pine Creek orogen, the Arnhem Province is a Paleoproterozoic terrain which experienced regional metamorphism at around 1880 to 1860 MA, followed by a subsequent phase of intrusion by A-type granites. Potassium-argon ages for the Arnhem Province similarly suggest the region did not experience major thermal perturbations following around 1750 MA, although the region is presently overlain by multiple Proterozoic to Cenozoic basin sequences. Samples from the Arnhem Province have been analysed for apatite fission tract thermochronology to attempt to resolve the subsequent thermal history of the region following these high to mid-temperature constraints. Using apatite fission tract data, we have produced low-temperature thermal history reconstructions for the Arnhem Province, as shown here. These thermal history models suggest notably slower cooling in the Arnhem Province than in the Pine Creek origin, although this cooling does still appear to start during the Alice Springs orogenic event. The Arnhem Province also does not preserve evidence of a secondary reheating event as seen in the Pine Creek, which is absent in both the thermal history and the sedimentary records. Observed differences in the cooling and uplift rates in the two study regions during the same event may well be explained by pre-existing structural differences between the terrains. The Pine Creek origin preserves multiple northwest trending Proterozoic fault structures, while structures in the Arnhem Province are dominantly north-south orientated. Consequently, structures in the Pine Creek origin were more likely to be reactivated with a vertical movement component during north-south oriented compression as seen in the Alice Springs orogeny. This leads to increased, faster erosion rates in this region compared to the Arnhem Province. It is also interesting to note that apatite geochemistry in the Pine Creek origin preserves a shift from typical granitic rare earth element profiles away from the Pine Creek shear zone towards a depletion of light rare earths towards the shear zone, as shown in the plot to the left. This rare earth signature is typical of apatites grown in metamorphic or metasomatic conditions, and may indicate a phase of alteration or metasomatism around the Pine Creek shear zone, which has weakened the surrounding rocks and left the region weakened and more susceptible to later reactivation around the Pine Creek shear zone, which further contributes to later uplift. If we now consider how our data matches with other apatite fission tract studies in both the North and South Australian cratons, we can see that like these northern study sites, fission tract ages between 400 to 300 MA are incredibly common across Central Australia. This figure shows a compilation of apatite fission tract data from this study combined with many other published studies and presents the fission tract central ages preserved across Central Australia. The prevalence of Alice Springs age cooling signatures throughout the Central Australian corridor is suggestive of a widespread thermal event during the mid-Paleozoic, which may be linked to north-south compression during this time. It is also useful to consider the non-thermochronology sources in this investigation, most notably the widespread preservation of Devonian to Permian sediments across Central Australia. Together, the thermochronology and sedimentary records support a potential period of significant erosion of material during the Alice Springs orogeny, evidenced in the thermochronology record as a period of widespread uplift and cooling across the Central Australian corridor. In summary, both the Pine Creek origin and Arnhem Province preserve evidence of cooling and uplift coeval with the Alice Springs orogeny in Central Australia. This cooling pattern is replicated across much of the North and South Australian cratons, and may suggest the presence of a widespread mid-Paleozoic thermal event. Finally, the Pine Creek origin also preserves a later phase of reheating in the region, which is currently attributed to burial below the Money Shoal Basin during a period of local mantle subsidence. Thank you for listening to this presentation, and if you have any questions or comments on this work, please come along to the discussion sessions.